Hello, good afternoon, everyone. Let's get started. So today's speaker is Mr. Anik Bal. He recently graduated from Electrical and Computer Engineering here from Central Michigan University. And today he'll be talking on machine learning. So without any further delay, I would like to invite him so that we can start our today's seminar. So let's get started.
Thank you, Professor, for giving me such an amazing opportunity to come to attend this seminar and have some speech about machine learning. So, hi, I'm Anik Bal. I have just graduated my master's degree from the engineering department of Central Michigan University. So throughout my 2 years journey, I have been working as a graduate research assistant under the supervision of Professor Dr. Abdul Jawad. So I worked actually on power system security by implementing machine learning. So today I'm here to depict what is machine learning and where we can use it from a very basic level. So let's go. So today our objectives are, first I will define what is AI, I mean artificial intelligence, then machine learning and deep learning as well. After that, I will explain how ML works or deep learning works. And I can also, if we have enough time, then I can also can demonstrate some practical sessions of two problems. So these are the packages and libraries. If anyone interested to work in the machine learning, these things you have to know actually. Like you can see for the programming type works, you can use either Jupyter Notebooks, or if it's not installed in your computer, you can use Google Colab. And for the numeric computation, you can use NumPy and Pandas. These are very handy libraries invented actually to which make our work and life very much easier. So, and for the data visualization, there are some other algorithms. So these are the all list. When you start working, you need to know how and why you have to work. Use it. So first, what is AI? So we know that AI is currently a buzzword in the world. Every sector is trying to stay closer. Sorry. So everyone and every people are trying to, every sector are trying to implement this AI or machine learning in their work. So we have to know what is AI. So artificial intelligence is something that by using it, we will make our system so smart that can think like, or that can work like a human being. Like we are the smartest creature in the world. We can sense something, based on the sense we can act. For example, when if you go right now outside without any jacket or without any proper gears, you will feel cold. Why you are feeling cold? Because in your brain you are smart enough that can sense that outside is cold or warm. So artificial intelligence is such kind of system. It's actually broad sense. It's such kind of system that will make a procedure very smart, like a human being thinks. And this is actual artificial intelligence. For that, we use a lot of algorithms to make the system smarter. And then machine learning. So machine learning is a subset of artificial intelligence. You can see from the diagram. So in a big circle, that is artificial intelligence, and in between, in the artificial intelligence, machine learning is the subset. So how, now the question is, how we will make the system intelligent or smart like human being? So there are some ways to do this, to execute this. One way is to implement, to learn from the data, to learn from the patterns of the data. So what is this? If you look closely in the nature, you will find out some patterns. Like you can see easily if you see the weather of 1 year, you will understand that there is some patterns, like initially from January to, if I consider Mount Pleasant, from January to May, you'll feel cold, and after that it will be warm and again cold. So this is a pattern actually. So machine learning actually used to make a system smarter by using the patterns of the data. Like if you see a bulk amount of data, the machine can take necessary steps, or it can identify that what it has to be, what it has to do. So machine learning works based on these patterns of data. To do this, to execute this, we need to explicitly giving some rules or some formulas. Like for example, I'm saying a plus b whole square. This is, we actually will not giving these formulas in the system. Just assume that this is a formula. So this type of formula actually we are assigning in the system so that the machine can understand the pattern of the data. And the last thing is the deep learning. So deep learning is a subset of machine learning. I mean, it's included in the machine learning. So what is deep learning? Deep learning is much and more smarter than machine learning. So in the machine learning, you are giving some input. Based on that, you are having some output. So in between this input and output, you are giving some, as I said previously, you are giving some formulas, or we call it machine learning rules. But in deep learning, just think, between input and output, we are not giving any formulas or any rules. We are just giving some kind of human brains interconnection network, which I will tell details in some next slides. So this is the basic difference between machine learning and deep learning. In deep learning, you don't need to give any explicit function, any explicit rules. Rather, it can learn from input and output by some functionality, which I will discuss later. And also another big difference between machine learning and deep learning is that for deep learning, if your data set is huge, like in real life, we have to deal with a million and billion of data. So deep learning can handle this bulk amount of data. But on the other hand, the machine learning actually can't handle this bulk amount of data. And another issue is the feature actually. You have to identify in the machine learning, you have to identify the features very carefully, like manual. But deep learning, it can adapt automatically from its, it can learn the patterns automatically. So these are the basic difference between the machine learning, deep learning, and artificial. So all this machine learning, deep learning are part of artificial intelligence. So this machine learning is actually, I said, it learns from the patterns of data. There are some other algorithms like genetic algorithms, fuzzy logic-based algorithms, and some other stuffs are there. For those algorithms, they don't need any pattern-based system to make the system smarter. So those algorithms are also included in artificial intelligence. So artificial intelligence is a broad sense. Machine learning is also one part. Apart from machine learning, there are other things are also in the artificial intelligence. So these are the basic differences between artificial intelligence, machine learning, and deep learning. So what the machine learning, first I describe about the machine learning. That I told you first that for machine learning, the system or the model actually learns from the pattern of data. Like for that, you have to give some input as the data, and I will make some model. My model will learn the patterns from that data, and based on that, it will give some input, it will give some output. So that is the machine learning's work, and it's actually a rule-based algorithm, which I described previously. And for that, actually, you don't need to write down any explicit programs. Here I have given an example of how machine learning works. It's very basic things, like we use the emails in our everyday life. So we know that if you see that all the emails we are getting, not the correct emails, there are many spam emails which are not actually really important. So industry are using these machine learning algorithms to detect which email is spam or which email is not spam by using the different algorithms and techniques. This is a very good example of machine learning. And two types of machine learnings are there. One is called supervised machine learning and another is unsupervised learning. There is another one, I didn't mention it, it's called semi-supervised learning. It's in between this supervised and unsupervised learning. That is a little bit complex, that's why I didn't mention it here. So let's focus on this. What is supervised learning? So the supervised learning, you have a target. What is target? Like when you have a data set, first you have to read the data very carefully. Like you have to find out some, for supervised learning, the data you have, that data must satisfy y equal to fs function. Like there should be some independent variable, based on that some dependent variables. Like y equal to fx or y equal to mx plus c, we know that x is a dependent variable and y is x is independent variable and y is dependent variable. So in supervised learning, you should have these relations, like based on x, you should have some y values of your data set. That is called supervised learning. And what is unsupervised learning? In unsupervised learning, you don't have any y values. You just have only x values. So there is no target values. We use this unsupervised learning in a clustering systems actually, like to gather, for example, I can give a very simple example, like for Mount Pleasant, we want to classify some houses based on two-story buildings. So we will cluster the buildings based on two-storied. So this is a clustering system. So here you don't need to, in this data set, you will not have any y values, I mean targets. So that is the very basic difference between supervised learning and unsupervised learning. So most of the things or existing works we are seeing are surrounding us, most of them are actually supervised learning. We have x and based on that we have y. So machine learning algorithms, what machine learning algorithms are using in the world right now? You can see these are the mostly used machine learning algorithms in the world. Linear regression, logistic regression, decision tree, random forest, they have different use cases. Based on that, we use these algorithms. For today, we will just discuss this linear regression and logistic regressions in details. Rest of the things I will not discuss here, but if you are interested, you can see how they work actually. But these are the all overview of all the algorithms used in the industry, in the academia. Applications. So machine learning is are using everywhere. I have just demonstrated a few of them. Like previously I said, the spam detection and email is whether you get an email, is it spam or not. Then it is also used in the fraud detections, like any fraudulent activities is happening or not. Those things also your machine can easily identify. Also, it is using in healthcare, energy consumption forecasting, like weather forecasting every day. We are using the weather forecasting systems. Machine learning is using here to forecast the weather, or also it is using in the energy prediction systems, like what will be the energy today, tomorrow. This for there also machine learning is using. So these are a few of the uses of applications of machine learning used. Apart from this, there are many other places where ML are using. So types of supervised learning, I told there are two types of machine learning. One is supervised and another is unsupervised. So today our this discussion topics is based on the supervised learning. So supervised learning are again two types. One is regression. Regression means like if you want to predict a house price of Mount Pleasant, like you have some data set. For example, I have given someone has given 100 data to me. Suppose that I am the model. Someone has given 100 data to me, like to predict the house price of a Mount Pleasant. I will predict based on the data, what will be the house price. So here, the price is a integration, it is a numerical value. So it is a continuous thing. But there are some other problems, like previous slide I showed, email is spam or not. Here the decision is either yes or no, either 1 or 0. This is not a continuous value. It's kind of category. It's called categorical output actually. Like you have to say either it will be happen or not. But in the regression problem, you are predicting some numeric values. So that is the two basic types of supervised learning. I have shown here some examples of regression and classification, like home price or weather. What will be the weather data? Or you can predict the stock price. So here the prediction value is continuous, I described. And for the classification, like one email is spam or not, or the customer will buy the life insurance or not. Based on the data set, we can say that if you given an age group, the model can say, yeah, what is the probability of this person to buy the insurance or not. These are the few examples of regression and classification. So, excuse me. So to go further, we have to learn this in this vocabulary or terminologies used very much in the machine learning. So I can go in the next slide, that will be more clear. So what is target or what is features in machine learning? It's very important to know. See here, for example, I want to predict the house price of Mount Pleasant, but in which parameters my house price should be dependent or can be dependent. I have shown some few parameters. You can see square feet, number of bedrooms, number of restrooms, neighborhood safety based on a scale. So these are the parameter. Based on that, it's very normal. If you have a larger house or bigger house, your price will be much. And so here you can see the price is actually depend on these 4 parameters. There may be more parameters, but for simplicity, I have shown this only 4 parameters. So what is machine learning doing here? So okay, let's first introduce these things. So these things, you can see that square feet, number of bedrooms, these are called features. This is called features of machine learning. That and this is the price you are seeing. This is called target. This I need to predict. My model will predict the price. So first, your task is when you will start any machine learning work, you have to find out what is your X values, what is your Y, and what is your target. So my X values are here, my features, and my Y is my target. So you can see here my X values are 4 X value, X1, X2, X3, X4, and this is my Y. So my Y is dependent on these 4 X values. So my model, what my model will do, the model will do actually by seeing these 5 data. In the sixth time, I have shown here five data sets. Now, if I have given an unknown square feet, unknown number of bedrooms and restrooms and neighborhood safety, my model will predict the price. This is what the machine learning model actually does. This is how it actually predicts. So these are the very useful terminologies, like what are the features and what is your targets. And yeah, that is the data pre-processing. Well, in the real life, when you will start doing on machine learning, so the 70% of your work actually involves in data pre-processing, because in the real life, you will not get the very clean or clear data sets. There will be a lot of noise in the data sets. So first, before feeding the data into the model, you have to clean properly. Otherwise, you can't, like for example, you get some data and it's not like that you can directly feed into the model. Before that, you have some pre-processing steps, which we call data pre-processing. It is very much important things actually. So first, like you have to collect the data, then you have to clean the data. There may be in the data set you may have, like in the real life, you will collect millions, billions of data. So in those data set, there may be some data which are missing values on some unnecessary informations are there. So you have to first fix out those things. Then feature selection. I told you in the previous slide that these are my features. So these features, you see my output, what I want to predict, this actually depends upon your these features or the X values. So you have to select these features. Like you can get a data set where there may be 10 or more. Just for example, I'm saying there may be 10 or 15 X values or feature values, these guys. But not all the features are not useful to determine the Y. So that is a very crucial thing. You have to first find out which X values directly affect your Y values. Like this price here is price is my Y. So we have to find out, is there any non-important or less important X which is not affecting the Y. Those things you have to delete it. That is called feature selection. It's very important. You have to first select the features. And then data normalization. And this is a system actually. Like for example, again, I'm just looking here. You can see this feature is in square feet, and this is number of bedrooms. This is a numeric value in 4. So 2504 is a very huge difference. So what we did, we tried to make all the feature values in between 0 to 1, so that it helps to model to become more generalized. That is called data normalizations. So this is also very important part for your data. After that, you have to split the data set. That is very important. That I will show in the next slide. So data framing, what your data framing is doing. For example, you have got, I have got 100 data set. So first we have to split the data set. First, I have to train the model. Like I have first got some data set. I told like I have got some data set. Based on data set, I have to train. But if your training is done, your work is not done, then the real scenario will come. Then you have to test, because if you don't test your model, how will you say that this model is good or bad? You have to test it, right? For example, in the training part, in the first part, you are getting a very good results, very outstanding results. It's not a good, I mean, you should not be happy, because you have to wait for the testing. That is the main thing. So that's why we split our data set in two parts. First, it's called training data set and testing data set. So what is training and testing data set? To demonstrate that, I'm just showing this slide again. Here you can see there are 5 data sets. I'm just showing here just to understand what is this. Here you are seeing that there are 5 data sets, 5 sets. So these 5, just assume that these are my training data set. So by seeing these X values, what is the Y values? It's here. Now I want to give a new data, 6 number of data. But that 6 number of data set, there will be no Y value. It will have these X values, like square feet, number of bedrooms, and rest of this. Based on this, my model will predict what will be the price. So that is the purpose. So in the practical work, we split it in a training set and test set. So the training set, the model will see the training data set. The model will know that what is the training data set and what is my X and what is my Y. That will happen in the training time. But we should have also some data. The model should not see this. The model don't know what is this data. For example, during our exam time, our semester final, all over the semester, we actually trained, our professors actually trained us. Like this is the basic of this is these things. But during the test, our main exam, our professors actually don't help us, because that is the main test of how we learn. So machine learning model is like that actually. Like the test data set, it should be it should not be disclosed. The model should not know what is test data. Otherwise, it is not a test. If you, before giving the exam, if you know what is the exam, what are coming in my examination, then it is not a test, right? You know all the things. So that's why that is the main task of the data. After you get the data, you clean the data, and then you have to split the data in these two parts: training set and test set. Test is required to evaluate your model. Is it working properly or not? That is the data framing, and there is a very simple workflow how the machine learning works. First, I'm giving some training data. Training is happening, and I have get a model actually, which is already trained. Then I have to predict. That for an unseen or new data sets. So here you can see from the input in the second row, we are giving the test data set. Based on this test data set, my model is predicting like what will be the house price that I have explained in the last slide. Based on that, it will give the result. So that is a basic workflow of machine learning. First, you have to give training data. It will be trained. The model is ready. Now you will give the unseen data that your model never see. Based on that, your model will predict the value actually. So that is actually how machine learning models work. So now I will discuss that linear regression, a very simple algorithm. So what is linear regression? Linear regression, actually, we all know that y equal to mx plus b. There is the equation for a straight line. So linear regression is to in this model, actually, they use this simple y equal to mx plus c that formula. Here you know the m is the slope and c is the y-intercept. And for a straight line, based on your slope and y-intercept, you may have different lines actually. So here you can see that based on the area, we will predict some prices, and for that the data sets, you can see the red points are here based on these data actually. So I have to draw a line such a way so that most of the data should be covered. I should draw a line. I can draw a line this way. But my purpose, or machine learning purpose, the model's purpose, is to draw a line in such a way so that it should be close to these values. It should cover all the data sets. That is what we do in the linear regression actually. Like linear regression, actually, the machine learning predicts a borderline so that it is close to the real values. Here you see the linear regression, this formula we have used. This is same y equal to mx plus c, just in a different alphabet I have used here. See, there is as I told, which model fits the best, red, blue, or orange. So your model actually defines this, that which model, see here, you can here a bulk amount of data. In which way you have to draw the data so that you can cover most of the data set here. That is the main target of a linear regression of machine learning. So here what we do actually, see, based on the area, we are predicting the price. For example, if we consider Mount Pleasance, based on how much square foot, we are predicting the price of house. So based on that, we have some this type of data set. Area, based on area, we'll predict the price. So you see, for example, my model predict this blue color line. So, but you see the real values, the red lines are my real values are actually. So here actually we calculate how actually the model will understand that it is good or bad. You need some parameters. So based for that, actually we calculate the loss. What is loss? You can see from here. For example, this is the predictive line. My model predicts this is the best fit for my data set. But you see, this is the real data, but this is blue line is my predicted one. So the difference between the real value and the difference between the predicted value, you see red, and this is called the loss. So my model's main purpose is to reduce this loss, to reduce this perpendicular line. It is called MSE loss, or different types of loss we can use actually. So the machine learning actually adapt or updates its parameters or values based on these loss values. So we have to machine learning, the model have to predict such a line for linear regression so that the difference you can see it's huge. Here there is some difference. The main purpose of model is the loss should be less. So what is loss? The loss is the predicted value and my real value. So what is this for? To explain it more clearly, I can show you this thing again. Here I told you in the previous example that my main purpose is I will give a sixth value of, and my model will predict some price actually. But I told you that in supervised model, in machine learning, you should have some data that has X value based on Y values. So here I am my 6 number data is my test value, and I have square feet, number of bedrooms, all the things we have, and also I have the price. But as I consider the 6 value as my test value, so based on these features, it will predict a price. Then my model will test that these the prices, how the price is closer to the main value. So that is how it actually calculating the loss that I have shown here, that it's predicted value minus the observed value. So all the machine learning, deep learning, these models or algorithms actually calculate a loss with the real value and your predicted value, and its main purpose is to reduce the loss. So we use here mean squared error. So this is, I have shown a formula of mean squared error, how it's calculated actually. So now logistic regression. So what is logistic regression? I told you in the linear regression, we predict the house price. This is a numeric value. This is a continuous things, some numeric values. But in classification, you have some data set, like this is a dog or this is a cat. You have to identify, you have to classify either dog or either cat. Or for example, you can see that you have some data set. Based on that, your model has to tell with whether a customer will buy insurance or not. So the question is yes or no. That is not, output is not a numeric values. So that is called classification. That is a classification type problems. So how will you do the classification? I have shown a simple data set. You can see for different age group of people I have given here. Based on that, will they take insurance? If any person will take insurance, it will be 1. If the person will not take insurance, it will be 0. You can see the younger folks, 22, 25, most of the younger folks are not willing to take insurance because they are less prone to have sick or become weak. But you can see after 45, aged or senior people are more likely to take the insurance because they have more prone to attack by disease or anything. So they have some health insurance. So I have the data set like this based on the age, whether they will take insurance or not. This is a very classical problem of these logistic regressions or classification problem. So you see, if I plot the data set here, like 20 to 30, you see they will not take insurance. So I have plotted that this red things 0, 0, 0. So the folks age range between 0 to 30, they will not take insurance. That I have shown here, you can see. And the folks aged more than 45, you can see most of them will take insurance. So if we use here a normal linear regression, you can see it can detect it properly, like whether it's possible or not. You can see it's not covering all over the data. So to solve this problem, we use here actually logistic regressions, and a mathematic formula you use, it's called sigmoid function. Sigmoid function. So sigmoid function actually gives the output a probability. It gives an output a probability. Whether so in the probability, if you see, this is a probability line actually, like 0 to 1. This is a kind of probability distribution things actually. So if your it is designed in such a way in logistic regression, if the probability is more than 0.5, it will give 1. If your probability is less than 0.5, it will say 0. For example, the 22 years guys, if the model's probability is giving 40%, there is a chance that that guy can buy the insurance. So as it is less than 0.5, so that's why you are seeing here 0. For a 47 years old guy, there is a probability. I'm just giving an example. There may be the probability, or the output the model has given, the probability is 80%. There is a chance that that person will buy the insurance. So that's why my output will be 1. That we have shown here. So we have done these things by using sigmoid function, a mathematical function. So this is the sigmoid functions actually formula. How if you plot this thing, you will get a S-shaped function curve actually, which is there. So if you put your linear regression in a sigmoid function, it will actually transform like this. So in the classification task, we actually do these transformations by using these sigmoid functions. We actually classify whether if someone have given 100 data, 50 of cat's picture, 50 of dog's picture, then 101 time you have to decide like a picture whether it is cat and dog. So this type of classification things, they use this sigmoid function. Now here comes the deep learning. So this is all about actually the machine learning. I have tried to give very simple like just a basic ideas like how machine learning works and what algorithms they use. And here we comes the deep learning. So deep learning is a very smart algorithm, and it's just like our human brain. So for that machine learning, I told you to make the purpose of AI is to make a system smart like a human being. So how will you make the system smart? There are some things that like machine learning used some rule-based techniques, and deep learning is using your brain's neurons to make the system smart. So because in our human being's brain, you know, it's actually consisting of very tiny and small amounts of neurons. These neurons are actually are such strong. They are such strong and such smart. They are actually whatever you are sensing in your body or you are acting, all are actually coming through your brain. If you have any problem in your brain, your body will be not functional like this. So deep learning model, it is using such kind of human brain's functionality in between input and output. I will show a picture, then it will be very easier. You can see this is my input data, the blue one, and the green one are my output data. So in the machine learning, we didn't use these things actually. These small things you are seeing, this is called neurons. This is what we have in our brain. So in machine learning language, it's called perceptron, but we can say it's just for simplicity, we are saying it's neuron. So that's why you can see it's an interconnected. You just cut our human being's brain, and this brain, you are setting it in between input and output. So this brain, what is inside the brain, there should be a combination of neurons and interconnection networks. These things are, you can see in the hidden layers. We are saying the human brain's, this layer is called hidden layer. So like this, the neurons are interconnected with each other. So that's why it's called neural network, because it comes from the neuron of brain, the concept. So each of these is called actually neurons. They are actually learning. How they are learning? They are actually learning by giving the input you are giving. Based on the input, they are giving output. They are learning the way that our human brains learns. But it's an adaptive system actually. Like you are giving some input, and based on that, it actually creates a map between input and output. Based on that, actually, it gives the, I mean, based on that, it is giving the prediction. So, so that is actually deep learning. Deep learning is I am again saying, machine learning is a part of artificial intelligence. Deep learning is a part of machine learning. So deep learning is also a subset of AI, you can say, and it can work when you have a bulk amount of data. The much data you will give, it will be more smarter. It can learn more efficiently. So so in the deep learning case, the first thing is you need to give a proper output, satisfactory result. You should and must have a large number of data. But in a machine learning, you don't need a large number of data. The models are such way designed, then it can give a prediction of based on a very small amount of data. So it is the difference between the machine learning and deep learning, how they are working. You can see my work is to define, for example, this guy's name is Messi, not Lionel Messi, just random Messi. So how the machine learning is working, first I told you that it has to detect the features like the X values, and it has to find out the, based on X, how Y is related. Then some classifier algorithm, I told that it's a rule-based system. You have to give some inputs or some logics or some formulas here. Then it will say, yeah, this guy is Messi. But in the neural network, you don't need to do all those things. It is doing automatically, like the human brain works, by some hidden layers and some neural networks. It can tell more efficiently, yeah, this guy is Messi. So these are the best. This is the another basic difference between deep learning and machine learning. And this picture I have already explained that it has, these are the small neurons. So how the deep learning actually work? So there is actually two ways actually it works. One is called forward propagation and another is called backward propagation. So by doing forward and backward propagation, its main purpose, I'm not going into so much deep. There are some mathematical explanation, but I'm trying to make it very simple. By going the forward side and backward side, its main purpose is to reduce the loss. Nothing, very simple. Its main purpose is reduce the loss. To reduce the loss, it has to go one forward side and again in the backward side. So, but the main purpose is same. I have to predict something which should be much closer to the real value. That is my purpose. In this way, I can reduce the loss. So that's what it is happening in the deep learning as well. So that is actually a small, neurons, how the neurons works. There is some weight values, some bias, some activation functions. They have different works, what the activation functions were. Like activation functions, you can use ReLU and other stuffs to induce some non-linearities in the system. And you can see there is some weight and bias. So every neuron has their own weight and bias. So what is weight and bias? I told you an equation, y equal to mx plus c, here m is the slope and c is the y intercept. So weight is the slope and bias is here the y intercept. So here these guys main concept is in every layer that slope and that y-intercept or that weight, if I tell in deep learning's terminology, that weight and this bias, is updating so that you can fit a standard line that will cover most of your data sets. That is what actually inside it's happening. And types of deep learning models is feed forward. There is feed forward neural networks, and if you want to, what type of works you want to do, if you want to work with pictures, or then you have to use these convolution neural networks. If you want to work some time series data or some sequential data, you have to use these recurrent models. In recurrence, they have few models, and till now the most powerful model is the transformer model. This transformer is, we are using ChatGPT. So that ChatGPT is this transformer model actually. So that is a very, very powerful and strong model till now that invented by the scientists in this field actually. There is also some generative models, like they can edit a picture, they can create some pictures or data. These are called actually generative models actually. I mean, they can copy same thing, kind of. So these are the types of deep learning models have been using in this field. More or less, these are models are using. So what is the uses of this deep learning model? It is actually, see, in 300 years ago, the electricity has invented. It has revolutionized the world. It has changed the world. So it is assuming that AI will have this much impact on the world. Now it has, see, and just I'm trying to give some real life example. Nowadays, while you are typing your email, they are already giving you some suggestions. You don't need to think how it is happening. That is called natural language processing. For natural language processing, they are using these transformer models actually, and this also. So they can actually, like, for I say, for image data, there is some model, some algorithm. For text data, there is some algorithms. So different, they have different uses based on the situations. So this computer vision and this natural language is one of the biggest, significance impact in our life nowadays. We can see the language translation. It becomes very easier nowadays if you want to translate anything from here. And another thing, you can see that how Tesla's self-driving car is driving in the road without any human being. So it's really very interesting, right? So they are using different machine learning models here. They use their actually reinforcement learning, semi-supervised learning, and also few of these models. So like this, also it's assuming that like one day it may happen. Already there are some AI security teams are there, because the advancement and the improvement in such a way that one day it may happen that someone built a model that is more smarter than human being. That will be the problem. So we should not exceed our limit. So it may happen, like someone actually, see, we never thought before discovering the ChatGPT, you think how the life was. Now it makes like very, very easier. Everything we're giving is also the codes. There are some algorithms that can generate codes, Python code that can generate, and that can test your code as well. So it's actually, I mean, revolution. There is a huge revolution in the world right now because of AI, and it will coming and coming. And now also the robotic systems has improved a lot because of the AI technology. These are the few, example how the social media. See, like if you use the Facebook, you will see we are, and it has also some bad problem in the social media, because it is forcing us to living in a bubble world. Because in the social media, whatever you like, whatever your concept, your perception, based on that, the model will feed those connections to you. That's why in the social media, if you use Facebook or any Instagram, you will not see whom the people may find. For example, you have 100 friends in your friend list, but you will notice that only 10 or 15 people, their updates will always come and just circulating in your feed. But what are the 85 folks or 80 folks? But these 15 guys, they have similarities, thinking, process, everything. That's why your model can define these things, and they are actually forced to leave us in a bubble world. Actually, that is the you can say the side part or dark part, but everything has positive and negative. We have to just take the positive side from the advancement of technology. So this is all about today. Thank you. Any questions, please?
Okay, now the floor is open for questions. Let's quickly look at the chat box if there's any questions here. We can
Stop the share.
usually we don't do that. Anyways, you can unmute yourself and ask questions, and of course, if in-class students wants to have any questions, they can do so.
There. So how can AI be used for like water quality modeling? So that's something that I'm working on. So is there a way to or maybe specific suggestions for different AIs for like theoretical water quality modeling? Like I know something I tried recently was I wanted to ask ChatGPT like how many waterways are known to be affected by a certain water quality issue, and it was not able to tell me. So I was wondering if maybe there are other better sources out there for quick suggestions like that.
Well, yeah, it's possible actually. So first, like you have to see that what type of data set you have, like for your water quality. So your have purpose or your target is to determine the quality of your water. So you have to see that which parameters your water is actually depending. Like there should be some parameters based on that the water quality will be decided. So if you have a very not very large amount of data set, then you can go for the machine learning. And if you have a quite decent amount of data, you can go for the deep learning. So based on that, actually, you have to take decisions. But yeah, it's very much possible.
It's good. Thank you.
Yeah.
Okay, any other questions? Okay, if not, then let's thank our speaker once again.
Thank you. So yeah.
Yeah, is there any questions online?